Let's take a look at an example where we have to decide whether to use half-angle formulas or formulas that reduce powers. Now, if you are, given this kind of, that this is where the answer is going, then it should be pretty obvious to you that we need to reduce powers because we're going from sines to cosines and there are no powers over here. Even if you aren't given that as a hint as to where the path needs to lead you, just know that when we're trying to kind of reduce these things, we often want to get rid of the powers. And that's often the first step. So since we've got a sine function there, we're going to remind ourselves of our sine power reducing function. And that is sine squared, right, of x reduces down to 1 minus cosine of 2x all over 2. Well, in this case, we basically have sine squared of 3x squared, right, because it's to the power of 4. So if we apply this to this formula, right, we've got a 3x here, and this is supposed to be doubled. So this is just going to become 1 minus cosine of 6x all over 2. But then this whole thing is squared. Okay, but that's fine because the cosines aren't squared. The expression is squared. So let's work this out algebraically and see what we get. Okay, so we just basically kind of foiling it, right? So bring the 1 across, we get 1 minus cosine of 6x. Then we take the negative cosine, and we get another negative cosine of 6x. And then the negative cosine times this one gives us, x plus cosine squared of 6x, right? That's just 1 multiplied through and then negative cosine multiplied through. And then, of course, the bottom is 4 because 2 times 2. All right, we clean it up, right? Combine like terms. 1 minus 2 cosine of 6x plus cosine squared of 6x all over 4. All right, so we've reduced our powers substantially because we only have one of them left. And so now we need to separate that one from the herd, right? Get the cosine squared out of there so we can deal with just it. So let's go ahead and do this division so we can split this up into individual pieces rather than one big old fraction. And we just get 1/4, right? Minus, well, 2/4 is just 1/2 cosine 6x. And then, of course, our last piece is plus 1/4 cosine squared of 6x. And that's the piece we need to further reduce because we still have a power on it. So now we have to bring in the formula for cosine squared reduction, right? And our cosine squared reduction formula is very similar. It's 1 plus cosine of 2x all over 2. So we're doing it with this, right? Of course, the 1/4 is still there. So we're going to put a 1/4 in front of this whole thing. And x goes to 2x, means our 6x will go to 12x, right? So this piece is just going to become 1/4, right, times this fraction. 1 plus cosine of 12x, right, because it's 2 times the 6x. Maybe you want to do this just to kind of, my writing isn't great. All over 2. All right, again, let's clean it up, right, by breaking it apart and distributing the 1/4. So we get 1/4 times 1/2. So there's 1/8. And then plus 1/4 times 1/2. So 1/8 cosine of 12x. All right, so this stuff is what's in yellow, right? We've done some augmentations, and these are now trading places. So we can bring this into that equation and add all of our like terms, i.e. we can add our two constants. So we have a fourth and an eighth, right? So that's 2/8 plus an eighth. So we end up having 3/8. Well, this is a cosine of 6x, and this is a cosine of 12x, so we can't add those together, right? So we're still just going to have minus 1/2 cosine of 6x, and then plus 1/8 cosine of 12x, and we've reduced it. That's it. We're pretty much done, and you can see up here that that's all they were looking for, because our coefficients are matching, right? We've got the negative 1/2 here, so this is just going to be cosine of 6x. And we've got the 1/8 here, so this is just going to be cosine of 12x. And then this number, this blank here, is where the 3/8 goes. Now, of course, if we wanted to, we could try to reduce the powers, or not the powers, sorry, use these half angle formulas to go from 6x to 3x and things like that, but it's just going to get very convoluted, right? We know that, for instance, cosine of 2x equals cosine squared x minus sine squared x. So if we try and take 6x, right, and basically this is saying we can cut it in half, and then we're going to have 3x. We're going to introduce powers. And now we're going to have powers with a 3x. So we're still not any better off. We're worse off, because even if we wanted to go further, we'd do half of 3x, and all of a sudden we're down to 1.5x. We can never get it down to just an x, which is why when we get rid of the powers, this is about as clean and easy to work with that we want to deal with, right? So that's what's considered reduced. Okay, hope that helps.